for attending this. Hopefully you'll get another insight into 2020. Unfortunately, Dr. Viswa is unable to be with us today, but he has made a film for us, which we'll play for you now.
Life, if you lose, you can get it back. For example, money, you may lose, you can get it back. Health, to a large extent, you can get it back. But time is one element which you cannot get back. And that is the time that you are choosing to spend with us. I'm sincerely grateful to you. And I hope the proceedings of this meeting, the things that you learn, the network that you're able to connect with, will make it really worthwhile for you to have spent this time, to have chosen to spend this time with us. Thank you. In addition, I know a large part of this audience consists of our customer base, people who are keeping us in business. I'm most grateful to you for your patronage. If you did not patronize us, we could not have grown and we could not have been in a position to offer this type of service to you. Thank you once again. Now, I just want to say a few words about the mission of the Viswa Group. You must have heard about Simon Sinek, a management expert, who says most businesses know what to do and how to do. These are the two concentric circles. And the third one is why they do what they do. So Simon says that the firms, the organizations that last forever and they graduate from good to great and they have sustainable businesses, they are people who know why they do what they do. Fortunately, in Viswa Lab, we have been very clear about why we do what we do. There has never been an ambiguity or a doubt about it. We want to serve the fuel using community, the seafarers and the people who monitor them, who are away from their family and who face all the risks to their lives in the wide sea and taking all the risks that go on, and there is no help. They have to rely entirely on their own initiative to solve problems. To them, it's really unfortunate that the adulterated fuels cause them so much of anxiety, worry, and loss of peace of mind. This is something that we set out to say that we will help the people, the ultimate fuel users. And I was a CMAC, I've been the CMAC committee member for almost 16 years now. And one of the things that struck me was CMAC is full of well-intentioned people, but there is a very small representation of those who use fuels because they're scattered.
Good afternoon, ladies and gentlemen. Welcome to the IMO 2020 Preparedness Seminar presented by the Viswa Group. This will consist of 5 separate presentations. Firstly, we have the introduction by our new COO, Dr. Alan Korshed. And Dr. Korshed is the Chief Operating Officer of the Viswa Group. And prior to this, Dr. Alam served as the Vice President and Regional Manager of Maritime Advisory of DMVGL and was the Managing Director of Future Ship Singapore between 2012 and 2018. He served as the Director of Engineering, Energy Management, Environmental and Research and Development in APL from 2006 till 2012. And Dr. Alam is a Chartered Engineer and a Fellow of IMAREST and RENA. He acquired his Bachelor of Science in Marine Engineering from Australia, and subsequently he received his MSc and PhD in Marine Technology from the University of Newcastle upon Tyne in the UK. He's also received his second PhD in Environmental Science and Engineering from the National University of Singapore. Dr. Alam has published many research papers in engineering and science journals.
This again, his welcome message you heard. Can you hear me? I'm not really sure. And so I'm here to welcome you one more time. Thank you for taking your time. As Dr. Vish mentioned, time is very precious, more than money or health. Though I would say health is very precious too. But anyway, nowadays we can prepare our health in many different ways as long as we have money. So that was the thing. So today we are here. Basically, I'll touch on that IMO 2020 preparedness. This is basically knocking at the door. And as you heard that I was from DNVGL, and then again DNVGL, it is the hot topics. And I understand this morning somewhere in Singapore, DNVGL also had a seminar, maybe the same subject was touched on. So, but again, let's go over it one more time and see whether we can share some knowledge, what we have and what you have. And with that, I move on. So first, I will cover the preparedness, certain things to consider, and why we should be prepared ourselves for whatever we are preparing for. And second presentation I'll have on basically on scrubber, and with that the Viswa scrubber specifically will be highlighted. So let's start with preparedness. First of all, this one you have been seeing again and again, and all these people here, many of them with gray hair, but I would say that these are things we see all the time. Just to highlight that these rules keep coming, and then it will keep coming. It will be more for water emission or air emission. Predominantly, these two sort of subjects will dominate in IMO for quite some time. So today, among all the rules, we talk about sulfur emission is the hot topics. Next phase, of course, we all know NOx also coming in, and CO2 also will come in. So these three emissions, one way or other, along with ballast water treatment and all those water emissions will come into play. So today's topic is basically 0.5% sulfur cap that is coming into effect 1st of January 2020. So what we need to know about 0.5% sulfur cap. Options. Let's jump onto these options straight away. We know 0.5% sulfur coming. And
Our next presenter is Captain KK Mukherjee, who's the Director of Operations at MYK Bulk Ship, and he will present Scrubbers, an option for 2020. Captain Mukherjee took up a sea career after graduating in science with a distinction in 1977. He has obtained the highest professional qualification of Master while serving at sea. He also holds a Master in Law. His career has spanned over 18 years on all types of vessels and rising to taking command of VLCC oil tankers.
Such a, I must say, very elite audience here. I'm from the industry, and I'm just here to just run through to some of the perceptions we as a ship owner feel. And I'm not going to speak anything new because most of it is there in the newspapers or daily bulletins, and you must be going through it well. But let me begin with it. Once again, very good afternoon to ladies and gentlemen. I hope you are the genders here. So, going forward, I'll just run through what we see every day. And I'll repeat the same perception which other owners share, and we also agree to it. You must have seen in the recent newspapers, I've just quoted some of the big ship owners, the big operators, and you can see here one of the CEO, as he mentions, that is the worst regulation conceived. Before I do that, can I take opinion, how many of you are actually fitted as scrubber or already working with scrubber? Can I take a head count, please? Very good. Of course, you can see the numbers. Maybe it relates to the percentage of industry we are expecting to have scrubbers. So, this speaks much of it, that what is the option we have and what is the best option. And again, as Dr. Vish mentioned, that most of the business people know what to do, why to do. So again, it's up to you. What's the way forward? So you can see here, was, of course, again, once again say, using low sulfur oil is the best solution. The ICS Secretary General says, scrubber a no-brainer. The Lord Offshore says the use of IMO 2020 compliant fuel is charterers expected. Of course, again here, there are different sections where you belong to. If you are a charterer, of course, it's going to eat you more. If you are an owner, operator, using your own vessels and have to provide bunkers, again, it's up to you. So it depends on which side of the fence you are in. So that's why the decision of scrubbers relates to your business, your requirements, and how you trade or how to go about it. Again, you can see HEPA oil, decisions are made widely on the technology. So it's a very valid opinion, because there is no silver bullet or solution to this problem which we are faced with. And you can also see the other end. We have seen the numbers. As you know, the estimated number which will come to almost 3,000, a good number. But roughly, as Dr. Al mentioned, can be 4,000. But again, if you compare it, the percentage is about 5 to 6% of the total fleet in the market. Also, you have seen that in recent report, almost 63% of the installed scrubbers or scrubbers order are open loop system. So these are the drawbacks of scrubbers. Well, will that open loop suffice in the coming years? And I just put some remarks in the recent news. You can see one of the big ship operator, Ten Energy, they mentioned that there is a concern about open loop system. The alpha level actually approached the club that whether the open loop should be allowed or not. Because we in the industry always take such technology, and in a few years' time, we see things changing very rapidly. And these are very cost-oriented equipment. The cost of scrubber is nothing unknown. You can see the industry, it will cost the industry almost 20 billion. Just an estimate. The total cost to the industry can be in the range of 60 billion because of the change of bunkers. So these are all estimates and given by the consultants, the qualified consultants in the market. So once again, as we are nearing it, the initial figures were about 1,000 scrubbers by 2020.
The next presenter will be Dr. Alam, and he'll be presenting Viswa H scrubber, a presentation with a Q&A session afterwards.
Of the seawater. As you know, the seawater is alkaline, and the whole idea is to neutralize that sulfur effect SOx in the emission. So by using that alkaline water, we try to neutralize the acidity of the gas. In that regard, there are two types of scrubber predominantly. One is the open type, another one is the closed type. And open type, basically, you just wash the dirty exhaust gas, and then after neutralizing, the effluent or the wash water goes down to the sea. And the closed loop system means you can't really discharge anything, or you don't want to discharge anything to the sea, and that is very much needed for when the ship is in port. Many ports actually don't allow you to discharge, so you have to use the closed loop system. And for that, you need the sodium hydroxide or magnesium hydroxide to neutralize. So in essence, open loop system is a very simple system, but closed loop is quite complex, and with the complexity, the cost also comes in tandem with the complexity itself. And when we talk about scrubber again, one is the open loop and closed loop. This is one way to look at. Another way to look at, is it in line with the exhaust, or is it like a multi kind of inlet tower? So in line means you remove the silencer, and then you can shove in the scrubber there, and that is in line. There's very limited of those kind of sort of opportunity to do that. Most of the scrubbers you'll find is the multi inlet tower, because we have main engine, we have auxiliary engines, and we have boiler. So that is the ones most common. So it is inlet type is another way to distinguish the scrubber. Now, types of scrubber share, as Captain Mukherjee mentioned, it keeps changing. This slide is quite old, I would say. In this slide, you'll find closed loop system was dominating more or less, or almost the same level like the open loop, very close to each other. But then again, now open loop far superseded that closed loop system. I'll touch on that in subsequent slides. Then again, that is about the open and closed loop type market share. And then again, another way to look at how about this scrubber type in the different segment of the trade, like container, like cruise ships, like tankers, so who are actually heading in that scrubber installation or in order. And then again, another one, is it the inlet type, the multi-inlet, or is it like replacing the silencer? So in that first one, you can see the cruise ships. It is one very dominating one. And I understand this kind of thing came from, as Captain Mukherjee said, who will pay for the freight and all the consumer pressure. Because of the consumer pressure, more or less the environmental regulation comes in, but when it comes in, it's the consumer who should pay the price. It is very fair. So in that sense, the cruise ship, in this case the driver was one single case, is that one cruise ship owner, or a group of sort of stakeholders, they took a ride in one of the cruise ships. And the story goes like that: when they got off the ship, they saw a lot of smoke coming out of the ship. And they said they didn't like it. They said, "We'll do something about it, otherwise we will draw our share from your company." And overnight they have ordered many, many scars. So they are really dominating the cruise ship in that sense. But the other one is the scrubber type segment, is down below. It's in that, is it a single or is it multi, that kind of thing. This is again a very interesting thing, because when you do your cost-benefit analysis, when I say that you go for open loop, so if you go for open loop, then you should be knowing that in some part of the world they don't allow you to use the open loop. You can't really dump the effluent or the wash water to the sort of the coastal area or at port.
And the next presentation will be 2020 Marine Fuels and the Recent Issues. And this will be presented by Mr. Deepak Cameron of the Viswa Group. Mr. Cameron is a marine engineer, and he has sailed for 14 years. And he's worked in ship management companies in various positions for 12 years. He's managed startup companies in diverse fields such as ship management, airport and e-newspapers for ships. His last 16 years before retiring in 2017 have been in a NASDAQ-listed specialist chemical company dealing with fuel oil upstream, midstream and downstream.
I hope you had a good tea break. We are running about 70 minutes late, and that's just keeping you away from the bar. And I don't want to do that. I'll try and finish this in 10. I'll try. But you know how it is. We people, when we give a chance, we don't want to stop. So, I'm going to talk about fuels, and as quickly as possible. Of course, as we all understand, effects of the new regulation trying to convert 250 to 280 million metric tons of high sulfur fuel or 3.5% sulfur fuel into 0.5% sulfur fuel is an onerous job. It's not going to be easy. So there's going to be a lot of stress on the refineries and how they are going to do it to try and meet the marine requirement. And as Dr. Mukherjee said, or Mr. Mukherjee said, only 6% of that will be staying back to 3.5. The rest of us will be moving over to 0.5. That is not only going to affect the mid-market, it's also going to affect the upstream. That means to say, pulling out the oil from the wells. And the refineries will have to come up with new processes. So availability and price, I think we've discussed enough. I'm not going to go there. We'll talk about the quality of fuel and the problems due to the change in crude slate and the new processes that will be adopted by the refineries. Here's a very simple graph or chart that I've drawn up. We have two possible ways of getting 0.5% fuel. One comes from the refineries, the other are the traders. Refineries have various choices how to come down to 0.5. The simplest, of course, for a refinery which is not very modern would be to use low sulfur crude oil. So if I use low sulfur crude oil, for me, I don't require too many processes in the refinery. It is easy for me to refine, blend, and supply the 0.5% sulfur fuel to the shipping industry. A refinery which is more modern and has the new reactors in place already, and believe me, there are enough. It is because of that that CE Delft, in their report to IMO, said that they would be able to convert, or the industry would be able to convert 190 to 200 million metric tons into low sulfur fuel. How can they do this? They will use a mix of crude, whether they use any crude. They will have to work out their economies, they'll have to work out what processes they have. How can they blend the crude to try and maximize the output from the refineries to meet the demand? So they have, of course, they will refine, then they will blend and come down to 0.5. They could go into hydro-treating. We'll talk about hydro-treating. What is hydro-treating? They can go into hydro-cracking and then hydro-treating, or they can go in for this new thing, which is known as hydro-conversion, which is what CE Delft in their report banked on going to the IMO. The traders, of course, are traders. They will buy anything and everything from anywhere and everywhere, and they will blend it as per your requirement and give it to you. And of course, the standard that is applicable in the market. And they will give you 0.5. Please just keep this one slide at the back of your mind, because the entire presentation is going to be based on this. I'm going to go at the refineries first. What are the refineries going to do? The refineries will blend their residue with cutter stocks to try and meet 4 predominant parameters which are critical to the marine.
Our next presenter is Mr. Amitava Talukardar, the Technical Director at the Viswa Groups, and he'll be presenting VEMS, the Viswa's Vessel Energy Efficiency Management System. Amit has been with the Viswa Group for more than 11 years and is responsible for managing the testing services and software activities of the group within the region. Apart from sailing as a marine engineer, he's also worked with ship management companies, engine makers under various capacities. His team was involved in the development of the Vessel Energy Efficiency Management System, which has been successfully installed or in the process of installation for over 200 vessels.
Are very close or has become very close to our heart. If it is not, there are market forces to make it close to your heart. And there has been several measures to improve energy efficiency has been adopted with remarkable results. But there's one which outshines all of them. The IMO record shows between 2007 and 2012, this particular method reduced daily fuel consumption by 27%. In these proper management techniques and utilizing those resources, post slow steaming, there is a possibility to further improve 25% energy efficiency of your ships. Ladies and gentlemen, good evening to you. And today our main topic will be this, that the beams or similar systems can be utilized in a very technical way to actually realize the saving potential and how the product looks like. Now, if you think 25% was a very big number, this is particularly put up for you. We have just taken 3 sister ships, and you can see the people who says weather and speed, they are more or less very close. And we took the mileage, this kg per nautical mile, we call it mileage. That means how much fuel you burn to travel 1 nautical mile. And here you can clearly see that ship A 170 kg per nautical mile as compared to ship C, the best performing one, 145. And in percentage, this means that ship A burns 13.3% more fuel, whereas all of them are more or less, sister ships, and there's not much of a difference there in their designs. We have already crossed half or 50% of the 25% target we set. Now, we know you are very busy, and that I don't tell you, but you tell us that there is no time to spend too much time on looking after screen and find out what has happened. You need something very simple, a tool that can easily relay you the information, and then that can be siphoned down to the next level to do further investigation. So what we do essentially is to give a score to the ship and see that the ship A, which was worst performing, has scored 91. So the top management to find out, oh, this is not good, and pass on to relevant department, which you can identify from here, is more or less technical, except probably one of these EU OI, which will address your operational efficiency. So you can see here that the fuel consumption is almost 10 metric ton per day more as compared to the best performing ship. Now, after slow steaming, if there is anything that could say something similar to that level, is the hull and propeller condition monitoring. It's got huge potential of saving, and hull and propeller condition monitoring is.
So, in be it in model or be it in any calculation, you have to validate that. So I said, okay, we did some calculation, many of them, not some. And then we found as per calculation is not necessary. And then we validated with the actual installation of the scrubber. And then we found that, yes, they haven't installed any generator. Coming back to ballast water treatment and the scrubber. Ballast water treatment, in a way, again I said, if you remember, it depends on the operation metrics. In the scrubber, you have a very wide operation metrics. That means at port, maneuvering, anchorage, loading, unloading, high sea. So in that spectrum, all the scrubber pumps are load dependent. So depending on the exhaust load, then pump, whether two pumps need to run if there is some design, or one pump runs, even at port, at times on a single pump, a variable frequency drive pump runs at a very minimum load because your exhaust load is pretty low, auxiliary engine and the boiler running. Having said that, for a VLCC, maybe a steam-driven pump, loading, unloading time, the power requirement in the boiler is even higher than the main engine. So there will be cases in their operation metrics. So talk about the ballast water. It is a single kind of, often, is a single part of that matrix. When you do the ballasting and deballasting, you don't do it, say, maneuvering time, loading, unloading time, high sea and all these things. It's very rare. And that is why most likely you have to consider that for ballast water treatment is a necessity. Because ballast water treatment is not those kind of load dependent. There is some of the UV system, depending on the turbidity of the water, the energy, it is very energy, could be very energy intensive if the turbidity of the water is high. But usually electrochlorination and all other, they just go by the volume of water you have, and they are not microorganisms load dependent. Hopefully I answered your question.
Good evening. I have a short question for Mr. Deepak. My name is Captain Ison from Asiatic Lloyd. We talk about this, let's say, the cracking of the fuel and all the compositions, but what about the compatibility of these low sulfurs? If we have a tram vessel loading these bunkers in Houston, discharge after that we need to take in Rotterdam, less ROB in the tanks, are these compatible or no?
Like I said, Captain, we have 6 methods of getting 0.5% as per the chart that I showed you. And they have different kinds of input, different kind of processes in the refineries which we don't know. But in all probability, they are not going to, whether it's going to be compatible or not, I cannot give you a guarantee. But in all probability, I don't think they will be compatible. Because like I said, the feed, whether it is what kind of crude, what kind of processes, etc. It's can you mix them? I doubt it. It's an iffy thing. That's why my suggestion in the end was, please test the fuel before you use it. I think testing will take that much more importance going forward because we don't know. You know, previously making HFO or making MGO was run-of-the-mill stuff. But now everybody is trying to bring down the sulfur level. They have different methodologies, and therefore I think stability and compatibility will become an issue. I hope I've answered your question, sir.
If I just add one sentence is that we often receive samples. Some are proactive, as Deepak said. You do the analysis before and see whether it has a potential to give problem. Another one is to often we receive sample, my fuel pump seized. Can you analyze the fuel? Do the post-mortem analysis. So there are two ways. The choice is, of course, all on yours.
Hi.
And finally, we have a vote of thanks by Mr. R.C. Bevnani, who is a graduate marine engineer from DMET and a fellow of the Institute of Marine Engineers, India. He has sailed as a chief engineer on large tankers and passenger liners. His experience includes 35 years in the American Bureau of Shipping as country head for India, Sri Lanka, Bangladesh and the Maldives. And he also holds a degree in law and arts and he has a passion for golf.
No, she feels happy, but in her own sweet way, she calls him a liar. He's a liar. Then if he says, I don't know, sometimes at least you must make up your mind what you want to say. You never know anything. Then he says, maybe you are never decisive. Maybe, what is this kind of answer? Maybe. Then he says, depends. And she's upset. She said, depends on what? You're comparing with some other woman? And finally he says, and then he said, I don't know. In your life, sometimes at least know what you're doing, what you're saying. Finally he said, okay, yes. So she's very upset. He said, I'm never going to talk to you. Poor fellow didn't have dinner that evening. So the scrubber was something like that. Nothing, whatever you tell, even the right thing, the convincing, the person is not convinced. If you tell him no, he wants to hear yes. Yes, he wants to say no. Anyway, moving on quickly. Very nice presentation by Dr. Alam, Deepak Kamran. Let me tell you, 2020 is almost upon us. I have seen some people say that nothing, what are you going to do? Nothing. You know, when time comes, charter will give the compliance bill, I want to. But believe me, it's not so simple, because even if he gives you compliance bill, you have to consider what problems will be there. I think we could come and elaborate on that part. And then finally, Amit told us about the energy efficiency. We got to make sure that we reduce the consumption of our fossil fuels. We got to reduce the emission of carbon dioxide, because we are heading towards disaster if we don't pay attention. Truly, we are heading towards disaster. So the environment is just going downhill. And we see more and more typhoons, more floods, more flooding. Certain low-lying areas will probably disappear after some time unless we act now. And Maldives, probably in a few years' time, will go all underwater. Even a big country like Bangladesh, if we don't care now, I think most of it will be underwater. So having said that, let me once again thank all the speakers, Dr. Alam, Captain Mukherjee, and thanks to the hotel management, the hotel staff for making excellent arrangements. Thanks to speakers, thanks to hotel staff, thanks to our staff, Viswa Lab staff, not Viswa Lab as a Viswa group, because as Dr. has already mentioned, our identity slightly changed from Viswa Lab to Viswa group because we are doing so many more things. So thanks to our staff, especially the ladies in our staff, they work very hard to make this function a success. As they say, actually, I always believe ladies are smarter than men. Another story, but let me say this, somebody was saying, behind every successful man is a woman. And then behind every miserable man is two women. So, be careful. Then finally, of course, thank you to all of you who are here this afternoon. You found a very good time to be here. You sat through all the presentations. I know it gets a bit heavy. You feel a little fatigued. But we are ready. We're ready with the mind. We're ready with the ear. So, light in your minds. Enjoy the drinks. ladies are going very slow. So one of the guys said, I'll go and tell them, please move fast because we're wasting a lot of time. The guy goes halfway and comes back. His partner asks him, what happened? You didn't tell them? He says, I can't because one of them is my wife, other one is my mistress. So this guy says, okay. Other guy says, I will go and tell them. He goes, comes back halfway. And he asks me, hey, you didn't tell them? He says, well, mate, it's a small world. So thank you very much. Please join us for the wine and beer and then subsequent time. Thank you.